Hello, 5th and 6th grade. This is your science video for Wednesday, November 4th, 2020. And so we're going to be doing two worksheets today. They are study guides, so they're review for what you're reading partly today and also what we read before. And so page 65 and 66, if you look at 65, it's going to be talking about stored energy, and what stored energy is. You should know that from yesterday's anyway. Energy an object has because of its motion, and that you should know that one from yesterday. The total kinetic energy of particles in a substance is called, and that is something that will be on today's. And then the measure of the average kinetic energy of the particles in a substance is called, actually, both of them were from yesterday, actually, I think. Number 5 and 6, though, are from today. Thermal energy is measured in what, and then temperature is measured with a what. And then 7, 8, 9, and 10, these are a blank is the ability to do work. The ability of a substance or particle to move faster and expand without changing states is called. Almost every substance blanks when heated, and when cooled, I can tell you that one expands and contracts. Expands when heated and it contracts when it's cooled. Temperature is usually measured in degrees Fahrenheit, or you should know that one from yesterday too, that's Celsius. A blank is the amount of thermal energy needed to raise temperature of 1 gram of water 1 degree Celsius. Thermal energy of a substance is determined by its blank, and then heating substance and all that stuff that's there. All right, so we'll go on to the reading. It's only 3 pages today, so follow along as I do it. I'm going to read quickly, so if you want to slow me down, you can slow me down, but I'm not slowing down. I have another audience today. So, matter and thermal energy, page number 92. You already know of ways that changes in thermal energy affect you and the things around you. If you wait too long to eat hot food, it cools off. If you do not eat your ice cream quickly enough, it melts. It gives you a sticky mess. A fire burning in a fireplace warms the air in the room. All of these situations involve the flow of thermal energy. State changes. The moving particles in matter attract each other much as magnets attract each other. The amount of attraction can vary, though. It depends on the speed at which the particles move. As the temperature of a substance increases, the speed of its particles increases. As the particles move faster, there is less attraction between them. Particles in a solid do not move very much. They just vibrate back and forth. Because their small vibrations do not force the particles very far apart, the attraction between the particles is great. In a liquid, the particles move a little faster and there is less attraction. Particles in a gas move rapidly and cover great distances. There is little attraction between the particles. As a substance is heated, it gains thermal energy. This additional energy causes the particles to move faster and to move farther away. When farther apart, they have less attraction. A solid may become a liquid, or a liquid may become a gas. If a substance is cooled, the opposite occurs. It loses thermal energy and may change to a state of matter in which the particles move less and are attracted to each other more. For example, when the gas in refrigerator tubes cools, it changes to a liquid. All right? Now, on the next page here, thermal expansion. Sometimes when the temperature change is not very great, a substance does not change its state. The substance's particles may only move faster and occupy a little bit larger space. This property is known as thermal expansion. And so they give you an example of a bridge. You may have seen bridges like this before where they have those metal grate type of things. So when the bridge is, in this particular picture here, would you say that the bridge was cooler or warmer? What do you guys think? Cooler or warmer? You guys even watching? You're not reading this with me? Okay. So cooler or warmer, well, that one looks cooler because it's far apart, but once it expands, those little teeth actually will move closer to each other. And the whole idea is to allow that expansion so that the road itself doesn't crack. That is really why you're trying to do that. You don't want the road to break because there's not room for it to expand. A liquid thermometer uses thermal expansion to measure temperatures. Thermometer is your secret word. When thermal energy is added to the liquid in the thermometer, it increases the speed of the liquid's particles. The liquid in the thermometer expands and takes up more space. This increased volume causes the liquid to show an increased temperature on the thermometer scale. The reverse is also true. When a substance is cooled, the particles move less rapidly and occupy less space. In this case, the substance shrinks or contracts. Almost every substance expands when it is heated and contracts when it is cooled. When the temperature of most substances changes only a little, they expand or contract only a small amount. However, even a small amount can cause great problems. Engineers must allow room for these small changes in size as they plan structures. If you look at a bridge, sidewalk, or highway, you may see spaces between the sections. These spaces allow the structures to expand and contract, without buckling or cracking. So it says try it yourself. You can take a balloon. You can put that balloon into the refrigerator or freezer, leave it in there for a little while, and you'll notice that the balloon is kind of just a little bit not full all the way. But then you take it, put it back out in the warm air, and it slowly gets bigger and bigger. And that same thing if you take it outside during the wintertime. If you're going to somebody's birthday party, that's another way to see it. All right, so the last part here, last page, measuring thermal energy. Since thermal energy and temperature are not the same, they are not measured in the same way. One of the units for measuring thermal energy is the calorie. A calorie, abbreviated CAL, is the amount of thermal energy needed to raise the temperature of 1 gram of water 1 degree Celsius. Raising a temperature of 10 grams of water 1 degree Celsius takes 10 calories of thermal energy. It also takes 10 calories to raise 1 gram of water 10 degrees Celsius. The amount of thermal energy required, depends on both the mass of the substance and its change in temperature. Stored thermal energy. Some substances cool or heat more easily than others do. This means that the substance has different abilities to store thermal energy. Perhaps you've noticed that in the summer the metal parts of the bicycle get hotter than the plastic parts do. Metals can store a lot of thermal energy. Even just a little heat will make them warm up. Plastics do not store as much. It takes a lot of heat to warm them up, and then they don't stay as warm as long. All right, that's it. If you missed the secret word, shame on you. Go back between 3 and 5 minutes and you'll find it. Have a wonderful day. See you tomorrow. Bye.